All right, welcome. Have you ever really stopped to think about how the internet actually works? It feels like instant magic, right? But behind every single click, every search, every video you watch, there's this invisible engine making it all happen. Today, we're going to pull back the curtain on that engine, a secret language called HTTP.
So let's just start with a super simple question. You see a link, you click it, and boom, a web page just appears. But what's going on in that split second between your click and the page loading? I mean, what's the magic connecting your action to that content you see?
Well, to understand that magic, we've got to learn the web's secret language. It's a protocol, which is just a fancy word for a set of rules, and it's called HTTP. This is, and I'm not exaggerating, the absolute bedrock of the whole World Wide Web.
So HTTP, which stands for Hypertext Transfer Protocol, is basically the official rulebook for conversations online. It spells out exactly how your web browser, let's call that the client, is supposed to talk to a website's computer, or the server, to ask for and get information. You know, the easiest way to wrap your head around this whole thing is to imagine a digital postal service. It's super polite and incredibly efficient. Every time you want to see a web page, your browser is sending out a request and the website's server sends a reply. It's just this constant back-and-forth exchange happening at light speed.
And this analogy, it is spot on. Your browser's request is literally like writing and mailing a letter asking for some info. And the server's response, the part that sends the web page back to you, that's the reply you get in your mailbox. It's a really simple but powerful way to think about it.
Okay, so if you're sending this digital letter, it can't just be a blank piece of paper, right? It needs to be written in a really specific way so the server knows exactly what you're asking for. So let's break down what that perfect request actually looks like.
See, every single request is built in a really specific way. First up, you've got the address. That's just the URL. Then there's the intent, which is a command telling the server what you want it to do. The headers are kind of like the from field on an envelope, giving context like, hey, I'm using Chrome. And finally, if you're actually sending info, like filling out a form, that goes in the body.
Now, most of the time you're browsing the web, the intent, or the method, is a super simple one called GET. Your browser is literally just saying, "Hi there, Mr. Server, can you please get me the contents of this page?" It's direct, it's efficient, and it is the absolute workhorse of the web.
So let's put the two most common methods side by side. A GET request is like asking for a menu at a restaurant. You're just trying to get some information. A POST request, though, that's like filling out the order form and handing it to the waiter. You're submitting your own information to the server, like when you log in with a username and password.
All right, so your letter is in the mail. The server gets it, it thinks for a millisecond, and it always writes back. And this isn't just some casual note. It's a very structured, very official reply. Let's peek inside the envelope.
And that reply? It's got three main pieces. First, a status code. Think of this as the delivery confirmation. Then you have response headers, which give a little more context. And finally, the response body. This is the good stuff, the actual content you asked for.
So what's actually in that body? Well, usually, it's a bunch of HTML code. Now, this might look like gobbledygook to us, but to your browser, it's the blueprint. Your browser reads this text and translates it into the colorful, interactive web page you actually see on your screen.
Okay, let's circle back to that first piece of the reply I mentioned, the status code. This little 3-digit number is a huge deal. It's the server's instant feedback, telling your browser right away if the request was a success, a total failure, or something in between.
And these codes are all organized into 5 main categories, which actually makes it pretty simple. If the code starts with a 2, that's great news, success. If it starts with a 4, that means you or your browser made a mistake. And if it starts with a 5, the server itself has a problem. It's a really clear system for figuring out what just happened.
When everything goes exactly as planned, your browser gets the best status code of them all, 200. Okay. This is the universal signal for I got your request, everything is great, and here's the data you wanted. It's the green light that tells the browser to start building the page. But we have all seen this one, right? A 404 not found error is a client error. It means the server's up and running just fine, but the specific page you asked for, it doesn't exist. It's like the post office sending your letter back stamped, address unknown. Usually, it's just a typo in the URL.
So this whole polite, orderly postal system works incredibly well as long as everyone plays by the rules. But what happens when someone decides to abuse it and just send way too many letters?
Now here's a really crucial detail. HTTP is what we call stateless. That means the server has like short-term memory loss. It treats every single request as a brand new conversation. It has no idea who you are, even if you just asked for something a second ago.
And that stateless nature can be taken advantage of in what's called a DDoS attack. Attackers use armies of computers to send millions upon millions of HTTP requests to one server, all at the same time. It's the digital equivalent of flooding a single mailbox with so much junk mail that the real letters just can't get through. The whole system just grinds to a halt.
And that's the wild part, isn't it? The very thing that makes the web so fast and scalable, this simple, forgetful conversation, is also its biggest weakness. The web's greatest strength is also one of its greatest vulnerabilities.
So, when you put it all together, just remember this. From that one tiny click on your phone to the massive global network we all rely on every day, it's all built on this simple back-and-forth conversation. HTTP is this quiet, unassuming protocol doing all the heavy lifting to build our entire digital world.
And that kind of leaves us with one last big thought. This digital postal service has worked incredibly well for decades, but technology never, ever stands still. So the real question is, what will the next secret language of the web sound like? What's going to power the internet that you and I will be using tomorrow?